advantage of Zoom lectures. When I finish, normally when I give Zoom lectures, I may post, I'll record it and post it in the classroom also. So again, this is chapter 4 of our course textbook, Writing Crisis. Here, I wrote chapter 4, part 1, because part 2 covers the Java effects. As we can see on this, the classroom, we have 2 different slides. So our main objective in this chapter is to focus on how, again, as we say, chapter 3 teaches how to use classes. That's again, user defined, which we said that we have been using predefined classes from Java API, which is application program interface. Now here we are going to define our own classes. So this will be a user defined classes. So which, first of all, we shall start with what is a class, what it consists of, and also how to define it, and then we move it from there. We may talk about a special method known as constructors. Normally, every class must have a constructor, because a constructor is a special method that will initialize the object you are creating. And normally, the constructor name is the same as the class name. It doesn't have a returnee type also. And sometimes it may have a parameter. So if you have a parameter, means we are going to create the object based on the parameter values. If it doesn't have no parameter, then default values, normally it will be, if it's integer, it will be 0 or null, etc. So that's our main objective. So let's start. First, we're going to talk about the structure of a class, or the anatomy of a class. Then we talk about the concept of encapsulation. And also we talk about the structure of a method, or the anatomy of a method. Now, in object-oriented programming, here we are not going detail. Later, I think somewhere around chapter 8 or so, we may cover in detail object-oriented programming. But in object-oriented programming, we have 3 main features. One of them is encapsulations. Then another one again is inheritance. Then another one also is polymorphism. So when we talk about object-oriented programming, what is encapsulation? It kind of bring the idea of security. So every class may have its own data members and its own method. And now the data members, we can have some as a private. A private data member means only that class can use it, can use those data members. A public means now I'm given an option that if I have other classes in my program, those classes also can directly access my data members. Then we have a protected. A protected means if one class inherits from another class, those 2 classes have inheritance relationship, they can directly access each other data members. And we may talk about this actually somewhere around chapter 8 or so. In this chapter, we may go through the concept of a kind of introduction to object-oriented programming. So again, that's our main objective for this slide. This slides. What is a class, definition, etc. And also we talk about methods. So writing a class, here we say the programs we have written in our previous example, which is in chapter 3 mostly, we use predefined, or we use classes that are already in Java API. So we may call it the predefined classes. Or here we say we use classes defined already in the Java API. So the example of classes we use in chapter 3 again was we use the string class, we use the math class, also we use the random class. Now we are going to learn how to design our own programs, and also using classes, programs that rely on classes. So which means we have to design our own class. Normally a class will be like a user-defined data type. Then when I have the class, I can go to the main method and create the objects of the class, because we know already that the main method, that's where execution takes place at. So I may have my own class outside the main method. Then inside the main method, I will declare or create an object type based on my class. And from there, I will use it. So class is kind of like a placeholder. Or let's say if we are building a house, I can have the blueprint of a house. So a blueprint of a house would be like a class. Now, when I build a house, the actual house itself, it becomes an object. So I can use only one blueprint to build the same type of house, maybe 2, 3, any amount. Same thing, I can have a class name employee, and I can create more than 10 employees. So that will take us, anytime we mention classes, that takes us to the concept of object-oriented programming. So object-oriented programming, everything is based on classes. And also here we say the classes will represent the objects. So we start with the concept here. As we can see examples of a class, we can see we have 3 columns. The first column will be the class name. Now, every class consists of 2 things. The attribute of the class, which will be the characteristics of the particular class type, and also the behavior, or here we say the operation. So let's take a student, for example. Now, if I have a student class, the characteristics of a student can be, let's see, the characteristic of a student can be the name, address, major, grade point average, which is the GPA, and then let's keep going. Now, when you are writing a program, you have to be careful the type of attributes you need. For example, if my program doesn't have much to do with the address of the student, I may not include it. If the GPA, maybe I may be more concerned about the financial aid issues with the student, then those are the information I will include. But here, let's say, example, we have a class name student. The possible attribute we have for now, it can be more than 4, as we said, but we have name, address, major, then the grade point average. Now, what kind of operations, the behavior of a student? Well, we can calculate the student GPA, or we can change the student major. We can also change the student address. Normally, we use the same set. So we can set the address, set the major, which means we are giving it a major or a new address, etc. Then also we can compute the GPA. Now let's look for the second example. We have a rectangle. A rectangle normally have only 2 sides, which will be the length and the width. But here also we included the color if it's important, because a rectangle can be blue color, yellow color, and you have a dimension of length and the width. So if that's the case, I can change the length, I can change the width, I can change the color. So that can be the operations or the behavior. Now, as time goes on, our operations become the method, and the attribute become the variables, or we use the term instance variables. So again, this is kind of like theoretical aspect, but we may see a code soon and see how it works. Now, I can also include calculate area or calculate the parameter, because we can calculate the parameter of a rectangle if we know the length and also we know the width. Another example is aquarium. What are the possible attributes or the characteristics? Yes, it can be the material we use. Also, the dimension will be the length, width, and height of the aquarium. So this means we can change the material or set the material. We can also set the length, set the width, set the height. And of course, if I know the length, width, and height, I can calculate the volume of the aquarium. And also maybe I can change, or I can even find the weight if it's filled. So compute the filled weight. And also we have a flight, the possible attributes, and also operations. Employee, we have the possible attribute. Employee, we can have the name, department, title, salary, etc. Again, the attribute can be more than 4, but for now we are using 4. Now, in terms of employee, I can calculate his wages or salary. If there's any bonus that can be given based on maybe some sales or hard working, good work or something, we can also find the bonus. Of course, when you make a salary, you have to pay your tax. So here we can calculate the task of the employee. The goal here, I want us to understand the basic theory behind classes. So a class consists of attributes. Later, the attribute becomes the variables or the instant variables, and also the operations. Operations, sometimes we may use the term behavior, and then later they become the methods. So for example, we have a class named vehicle. Well, a vehicle can have attributes such as the color of the vehicle, the number of doors, whether it's a rear wheel or front wheel drive or four-wheel drive. So these are all will be the characteristics of the car. Now, what can be the behavior of a car? Yes, we can drive it. We can park it. If we have to count something, how many doors we have in the car, we can set doors, etc. So always a class may have two things: attributes, operations, or the instant variables and the methods. So we got this idea also in chapter 1. In chapter 1, we discussed about, again, classes. And we shall see some example of a program name. In this case, we create a class for dice. So dice, for a class for dice, we can say, when we have a dice, what will be the instant variable? Maybe the color of the dice and also the face of the dice. When I say the face, whether the face is 1, 2, or up to 6. And we can have only one face at a time. So we don't need to say face 1, face 2, face 3. Face is face. Face can be 1 or it can be 2, etc. So I would say this is the two instant variable for a dice, the color and the face. Then what operations I can perform? Maybe I want to know the face that we have, or we want to change the color, etc. So this is, and also we have something called a UML diagram. That's a Unified Modeling Language diagram. And we have one diagram called the class diagram. And we may see the concept here. So this is what a class consists of. We have a diagram here. So this is our class. The first, as we said, the attributes becomes the data declaration. So the attribute will be the instant variables. Then the method, which was the operations or behavior, is the method declaration. So here we say the values of the data define the state of an object created from the class. So if we have the class for, let's say, a dice, one of the item will be the color of the dice or the face, etc. Now, the functionality of the method define the behavior. So I can calculate or set the dice color or calculate. I have an employee class, calculate the employee salary, etc. Those are behaviors. It becomes the method. So here we say for our die class, we might declare an integer called what? A face value. So a face value will tell us whether the value is between 1 to 6. We know a dice have 6 sides. That will represent the current value showing on the face. Also, one of the methods will be what? I can roll a die. So roll the die by setting a face value to a random number. Now, when we roll a die, we can use the random class and tell the die when we roll it to generate a random numbers between 1 to 6. So let's see how the program works. So this will be our first programming. And here we are going to create our own class, again, named die. So now the first thing I'll do, I'm going to have 2 files. So you can, first of all, if you are using Encapsulated or JGraphs, it's almost the same. I'll create file new and create a new project. Now, when you create a new project, the whole idea is that you are creating a folder. So that folder, you can create your die.java first, because that's my class. I'll save it in that directory, the folder. Then I'll create the rolling dice.java. Maybe this is where I have my main method to create the dice object and do all my operations. Now, die.java It's like I'm importing that. It will be like a package, but I created it. For example, when I want to use a scanner class, I didn't create a scanner class myself. I imported through the utility package. But this time I'm going to use a class named die. But we don't have die in Java API. So I'll create the die class myself. Now, if you put the die class in the same directory as the main method, the main rolling dice.java, then you don't need to import it. When you execute rolling dice.java, it will see the die.java since they are all the same directory. So let's see how this program works. So here first they start with the, actually let's go straight to the, I'll come back here again, but we can see that they are using the class already. So let's go. So this is our die.java. So this is the class that we created. So we have public class. The name of the class is die. We create a constant variable. We know the face is up to 6, so we say private. Now we are using a keyword private, as we said earlier, because we don't want this class data members, or in this case, mass variable. We don't want it to be directly accessed by other classes. They cannot do it. Even if they are inherited, they cannot directly access it. So we make it private for security. This is what we call the encapsulation. A class consists of its own data members and methods, and no other classes or other items in the program can directly access it. Now we can see our second variable, so we make it private for security reasons. No other class can directly access it. So with a die, we have only two things: the face value, and also here again, we don't really need this variable, but we are going to use this variable instead of using 6. Since if I'm going to generate random numbers, it's from 1 to 6, so mass is 6 for now. Now, previously I mentioned the color of the die can be an instant variable, yes, but in this case we don't. The color of the dice, it doesn't matter. We are not going to do anything with it. So sometimes we have employee class. Employee can have more than 10 attributes we can think about. Age, day was born. But if those variables are not necessary, we don't need to include it. So now next we have our constructor. As we said, constructor is very important. Constructor will initialize our object when we create it. So here we set, when we create a new dice, the face value will be 1, because in the constructor, we initialize it to 1. So after the constructor, now since here we have only one instant variable, which is the face value, that's why now if I have face value and also to set the color, then I can have the constructor also maybe color equal to red or something. It's up to you. But we have only one instant variable for the constructor, because in our class, we have only one instant variable. The second variable is just a constant value. So if no question, let's keep going. So next, we finish with the instant variables, it's only one. So next, what are the possible methods? It's okay, we can roll a die. Now, when we roll a die, what do we want to do? We want to generate any number between 1 to 6. So this is the reason why we are using the mass variable. So we don't need to declare, if you like, you don't need to declare the mass variable, constant variable. We can just put 6 here. So to generate any number between 1 to 6, we say mat.random times what? 6. We want to start from 1, not from 0. So we say +1 also. Then we're going to return the face value, whatever number we generate between 1 to 6. You can see that when we solely random, if we remember, random we generate any number between 0 to 1, but it will be decimal numbers. So that's why if we generate the number finish, we change it to integer. So even if I generate a number, since we had +1 here and we go up to 6, I can generate any number, let's say 2.3333 point something, all the point will be gone and it will be only 2. So whatever number we generate, mass again here is 6. So 0 to 1, we generate 0 to 5, but we say +1. So it will be, instead of starting from 0 to 5, it will be again 1 to 6. Now the next variable, the next method is called a mutator. We may discuss this more in an object-oriented program. When we create a class, we may have 2 types of method, which is very important. Those 2 methods will manipulate the instant variable. A mutator will change the value of the instant variable. So here you can see that we call our mutator set face value. We initialize it to the value that is in the argument, which means if I say set value 10, it means I'm changing the face value to 10. So you can see that we set the value that's in the argument equal to face value. So when I call this method, let's say I create an object named die1 or d1. So I can say d1 dot set face value, then the argument I'll say 2, which means I'm changing the face value to 2. Again, it's called a mutator. Then next we have an assessor. Assessor will Assessor will tell us the value of that variable. So you see here, we say return the face value. We're going to return the face value to get face value. So if I have object, let's say the object is D1, I'll say D1 dot get face value. If I print it, it will give me the current face value. So the last will be to string. Now, to string is a very special method that return a string representation of the die content. So when you go to the main method and you write a print statement, system.out.print, and you are printing some object content about this class die, the toString method will be called automatically. We don't call the string toString method. Anytime we use the print statement, it will automatically call toString so that it will format it for us. Here, we are not really doing any formatting. What we are doing is that we want to change the face value. So we use the toString method for the face value that we have. We assign it to a variable result, and we return the result. So what it does is that if I want to print anything, and I'm printing a face value, it will convert it to what is here for us and return it. So that's the end of our, so you can see we close the class parenthesis close. So that's the end of the die class. So this is like creating your own class. Now let's go to the main method. When you create your own class finish, you go to the main method, and this is where you are going to create the object. So here you can see that in our main method now, we have die. Die is the name of our class we create. So it's like declaring die1, die2 is like a variable, but here it's an object. The reason why it's an object, because it has its own methods and attributes the class represents. A regular variable may not have, it doesn't have its own method. So you can see that anytime we are going to use the method, we have to represent, we have to start with the object name. So I can say die1 dot set face value. So first we declare die1, die2, and we are going to add the 2 face values. So we have a variable named sum. So what we did here, we call the constructor. The constructor here, we create die1, and whatever default value the constructor value was 1, if we can remember, they set the face value to 1. So this means if I create die1 object, the face value is already 1. Die2 object, the face value is also already 2. Already 1, because we are using the same face value method. So 1, 1 for die1, die2. We can do this in one line. I can write die1 equal to new die constructor. So I can put a die here in front of die1 and die2. Then I don't need to declare it separately. So now you can see when we want to call the row method, what we do, we start with the object first. So here it tells me that I'm rolling die1 object. So die1.row. Next, I'm going to row die2. So die2.row. Now, when we create die1, die2, their default phase values are 1, 1. But when we roll them, they may have different values between 1 to 6. Our goal is to sum them. So here we said in the system.out.println, we say die1 value, then plus, then die2 value. And then this will be die1 and die1 row again. Then we change die2 phase value to 4. Then we add it again, which is here. Then we print our result. First, when we generate the numbers, we show the result. What is die1? What is die2? Then we sum them. So I'll wait for a few seconds if any question. So again, this is object-oriented program. First, we create our class name die. Now in the main method, that's where we create the object. So we create only 2 objects from die. We have die1, die2. The class name, then the object name. Then we don't have much methods here. So first we use the constructor. The constructor from the die class, I think again it was 1. So we can see the die constructor, the phase value is 1. So when you call the constructor here, you are giving die1 to read. Die1 will be 1, die2 also will be 1 because constructor, the phase value 4. Even if I create 10, die1, die2 up to 10, or the die1 to die10, the value will be 1 because they are using the same constructor. But now when I start to roll it, I can generate any random number for die1 and die2 between 1 to 6. So for example, die1 and die2 value don't have to be the same no more. Maybe die1 we generate 2, die2 we generate 3, or the numbers of course have to be from 1 to 6 based on the way you write the random method for it. So if no question here, let's keep going. So here what we did, we just system.out print die1 is what value, die2 is what value. We know the plus here since we have the values here. Die1, there's a string plus so we talk about this, I think, chapter 2 or so. If we have a string in the left and int or double in the right, we have use the plus, we are going to join the 2. We're only going to add if the left side we have numeric data type is not a string, and the right side also is not a string, then we're going to add. Okay. So next we roll die1 again. Then this time we set die2. So anytime we roll, there's a chance that we may get different value between 1 to 6. The phase value will be different. Here in the set die2, we set the phase value to 4. So we also print again, what is die1 now? What is die2? Now we want to sum them now. So here we say that die1 dot get phase value. Get phase value method, as we said, it to tell us what is the phase value of the method. And here, what is the phase value of the object? The get phase value is the method. So here we are saying that the object die1, what is the phase value for it? It will give you object die2, what is the phase value? So get phase value, return the phase value of die2 and die. Then we sum it together because the left will be a value, the right will be a value, so we add it, the plus will be addition. Now, if the left is string or the right is string and we have value, then it will join them together. So I'll wait for a few seconds if it's okay, or if we have any question. Okay, so let's keep going. So that's the result. Again, this result depends on we can remember we randomly generate, we randomly generate the values when we roll the die between 1 to 6. So we may, next time, if you run the program, we may not get the same values. And this is, we went through this already. Again, that's our die. As we said, the die class, the instant variable is only one, the face value. Then we have a couple of methods also. So this one of the method row set face value, get face value. So here we say the die class contains two data values. First, we have the constant mass, which doesn't have anything to do with the attribute of the dice. Normally, the dice attribute to be the face value. So we say the face value represents the current face value. Then we also have a method, row method, which we use. Row method uses the random method of the math class to determine new face value. Then we also has a method to expressly set, which we call the mutator, and also retrieve, which we call the get face value or getter. Sometimes we use the term set to be setter, get to be getter, or set to be mutator. Also, we saw the toString method. So as we said earlier, toString method normally will represent the object as a string. So in the year we say a good practice to define toString method for a class. The string method returns the character string that represents the object in some way. Also, this will be called automatically anytime when an object is joined to a string or when it's passed to println. So we don't have to call it. We also saw the constructor. So as we mentioned earlier, constructor normally its main job is to initialize the object we are creating. So anytime we are creating a new object, we have to have constructor. Constructor can be a default constructor most of the time. It doesn't have no argument. Then we have a constructor with an argument, and that means we can initialize it any value the argument have. So we will come to the concept of also a data scope. Normally we didn't mention that yet, but when we declare variable and we have a lot of methods or functions, which you understand how the data can be accessed and the range, I would say the scope of the variable. For example, if I create a method and inside that method, let's say method name area, inside that method, I declare variable name and the height. Well, since the variable is declared inside a method or a function, we will call it a local variable because it can only be accessed inside where it was created. Now, if the variable is created outside any class or any method, just outside, let's say it's created in a main method, then this we will call it the global variable, which means if I have 3 or 4 classes or functions, they can directly access the global variable. So a variable declared inside a method or a function can only be used by that function. A variable that is declared outside a function or method can be used by all the functions in the program. So here we say scope of the data is the area in the program in which the data can be referenced or can be used. So data declare at class level, it means it can be references by all methods in that class because it's in class level. By data declare within a specific method, that means it can only be used in that method. So we say data declare within a method is called a local data, or we use the term local variable. Now data declare outside a method, then it's called a global variable. We also mentioned the instant variable data, which we also use the term instant variable. So when we create our class name die, we have only one instant variable, which is the face value. So instant variable is like the characteristics of the object. Now, each instant, the reason why it's called instant, because instant will represent one object. So I can use one class to create 10 objects, which means we're going to have different instant variable for all the 10 objects. So here they say instance, or each instance object has its own instance variable. And also a class declares the type of the data, but it does not reserve memory space for it. So when you declare a class, it doesn't have no memory space. But when you use that class to create an object, that is the real object, then you have the memory space. So as we said earlier, the blueprint of a building will be the class. Then the actual building will be an object. So the actual building may consume memory. So they give us an example here. We can show the two die object from rolling dice programs following. So die 1, the face value is 5. Die 2, the face value is 2. So here we say each object maintains its own face value variable, and that's its own state. Now we can also use most of the assignment here. Always when we have assignment about creating your own class, we may say in the assignment that you should create or use UML diagram to design your class. Or you can create your class using your UML diagram. So a UML diagram is called a Unified Modeling Language. It consists around 14 different classes. So example would be use cases. Use cases to identify all the tasks that the program is going to do and how users will interact with the different features of the program. For example, if we create a, let's say, example of a library information system, where we can have a use case that the borrowers of the books in the library, they can only access the database with their books, so they can choose the right book. But they cannot update the content in the inventory, the database. That will be done by the manager. So here we identify the different users and also their use cases. So in this case, use case will be the tasks that each be done. We also have activity diagrams, so many of that, we said up to 14. But in this class, in this chapter, we're going to focus on only class diagram. Class diagram, we have 3 rows. So this is a very good example of a class diagram. 3 rows. The first row will be your class name. Second row will be your instant variables name. And the last row will be your methods. Now we can have a plus and minus. Here, the face value says int. We didn't say whether it's plus or minus, but sometimes we may have the plus and minus, which will represent private and public. So here we have the face value column and the data type of the face value. Or the method, also the method will start column and the returning type. So for example, set face value, it doesn't return any value. So they say set face value, the returning type is void because it doesn't. To string will return the string. And the first one, we can see that we have a rolling dice with only the main method argument. So again, it's a UML class diagram. Okay. So now we want to do some quick check here. We say, what is the relationship between a class and an object? Somebody can give us the answer. So for example, we say a class can be the blueprint, and object can be the actual house. So a class normally will not take any memory space or something, just a class declaration. From the class, we can create an object. Let's see the answer here. They say a class is the definition or the pattern or the blueprint of an object. It will define the data that it will be managed by an object, but it doesn't reserve memory space because we don't have actual content or object. So multiple objects can be created from one class, and each object have its own copy of the instant data, and also it will have its own memory space to store the data. Good. So if no question, let's keep going. Somebody should help us with this. Where is instant data declare? Let me make sure we all of us are in the classroom. I'm not alone in the class. Let's see. Here we have almost everybody. We have one more additional student. So somebody should give us the answer. So instant data will be declared, of course, in a class. And the scope of the instant data depends on the keyword public or private or protected. And local data means that data can be used by only a specific method, the method where it was declared at, or the class where it was declared. So let's see the answer. Maybe to be different words. For example, as we said, the instance data is declared inside the class. So here they name it is a class level. Then we say the scope of instant data that can be referenced in any method of the class. Then we say local data will be inside a specific method. So here local data is declared within a method and it's only accessible in that method. So wait for a few seconds if it's okay. So we make sure we understand the theory behind. Okay. So now let's move on. So we finish with the anatomy or the structure of a class. As we said, class normally consists of two things, the data members and the methods. What the data members can do, what the methods. Now, here we talk about encapsulation. Then the first thing that will come to our mind is the security of the data members. So here we say encapsulation, there are two views of an object. We have the internal view and also we have the external view. So internal view will be, again, the details of the variables and the methods of the class that defines it. And the external view will be the services that an object provides and how the object interacts with the rest of the system. Maybe an object will maybe interact with another object that came from different class, etc. Now, from the external view, an object is an encapsulated entity providing a set of specific services. So these services would define the interface to the object. So encapsulation, we can see how they explain it here means kind of related to security of our data members from different classes. So one object, let's say we call the object client, may use another object for the services it provides. So in this case, the client of an object may request its services. Requesting its services means calling its method. but it should not have to be aware of how those services are accomplished. And that's the concept of encapsulation. I know how to drive a car, but most of us don't even know how the transmission engine system works. As a driver, I don't have to know that. But maybe as a mechanic, that's where I have to know. So here we can say there's kind of encapsulation here externally, or I'm interacting with a car, driving the car, but what is going inside the car in details is not our concern. Now, any changes to the object state, which will be the variables, should be made by that object's methods. So this is the security we are talking about. If we have a class name employee have a method name set hourly rate. Well, the hourly rate is a private data or instant variable in the employee. So the only method that can change or can directly access the hourly rate or something will be the method that belongs to that very class. So here we say any changes to the object state, which is its variables, should be made by that object's method. Then we should make it difficult, or if not impossible, for a client to access an object variable directly. This is where we use the private. So I have two classes now, employee class and let's say vehicle class. I don't want a method in a vehicle to directly access employee data members. Same thing also, I don't want employee data members can be accessed again, or the vehicle data members can be accessed by employee method directly. When we say directly, we mean the method is using that data members in another class, access it, can change the values or can use the value. So the concept will be indirectly, which means I have to use the method of that class to get the data members. So an encapsulated object can be thought of as a black box. Its inner working are hidden from the client, same as I'm driving a car. I don't know the state of the transmission or how the gas exhaust system work every time. I have no idea. But again, I'm driving it. So that's the whole concept here. So to be able to do this, as we said earlier, we have what we call the modifiers and visibility modifiers: public, protected, and private. So public means, oh, well, that's good. And if I make a data instant variable public, it means now I'm allowing any classes method to directly access it. So most of the time we're going to make it private, which means no any other classes method can access the private members of another class. Protected means if those two classes have inheritance relationship, then they can directly access each other. So here we say protected modifier involve inheritance, which we will discuss way later, somewhere around chapter 12 or so. So right now, the program we are going to see here, we have a program with only one class. When inheritance comes, we can have more than 1, 2, 3, any amount of classes. Inheritance means at least we should have 2 classes, because one class have to inherit data members or methods from another class. So here we say the members of a class that are declared with public visibility can be referenced anywhere. So any classes can have access. Now, members of a class that are declared with private visibility can be only referenced within that class. The members declared without a visibility modifier have default visibility. Now, in Java, if you declare variable and you don't have the visibility modifier, let's say private public, by default is private. Then in Java, all the methods by default, they are public. So let's just say, okay, the method is private, then But if you didn't specify it, then by default, again, is public for methods. And for data members or instant variables, by default, they are always private. Again, our textbook Appendix E go details about how the Java modifiers work. So as we said about public, if we have public variables, then public variables always violate the encapsulation because they allow the client to modify the values directly. As we said, encapsulation is about security. We want to hide our data members from other classes. But if you make your data member public, that means you give it, any class can access it directly. So that's what we say. Therefore, instant variables should not be declared with public visibility. If you declare it as a public visibility, then there's no security on the data, which again, we refer to as encapsulation. Now, if it is accepted or acceptable to give a constant public visibility, which allow it to be used outside of the class, that's fine. If that way you design your program, you want it that way, you can use it. So also about methods that provide object services, always we should make it public. That's why by default, even in Java, if you didn't specify that the method is protected, private, or public, by default is public. Because sometimes we may have a method that have to provide services to other items in the program or other methods from different classes. So methods that provide the object services are again declared with public visibility so that they can be used or can be invoked by clients. Now, public methods are also called service methods. So a method created simply to assist a service method is called a support method. So we should know the difference between service method and support method. Now here we say, since support method is not intended to be called by a client, it should not be declared with public visibility. Only the service method should be declared as a public because they are providing services. So everybody should have, every element in the program should have access to it. So that's the whole concept of visibility modifiers. Variables always enforce the encapsulation. If you make it public, then there's no security. Method, you can provide services. The method that provides services to clients always make it public, because if you make it private, then they cannot provide the service no more. So you have to. But method that doesn't provide services, but rather they support other method in the class, yeah, we can make that private. So this would be a very general rules for visibility modifiers. Here you can see that they didn't mention no protected. Protected will come when we cover inheritance and polymorphism. So we saw a program called Accessors and Mutators, where we go through the die class. We say accessors are a special method that will return the value or the present value of the instant variables. So normally we can start the name with get. So if I have an instant value, let's say hour, the hourly rate, then I can have accessor name get hourly rate. Mutator will change the content or the value. So we normally use by default set values. So we say an accessor method return the current value of a variable, mostly instant variables, and the mutator method changes the value of a variable. So get X means we are accessor to return the value of X. Set X means we want to change the value. That's why they call it mutate to mutators. And we will see this always. So for example, if I have a class and the class have 3 instant variables. Then I'm going to have 3 getters and 3 setters. So getters and setters. Let's say hourly rate, get hourly rate, set hourly rate, name, get name, set name, address, get address, set address. Get address means I want to know the current address. Set address means I want to change the address. So we may have some mutator restrictions. Again, our time is going. I also wish they have a few more minutes. So we have something called the mutator restrictions. Now here we say the use of mutators gives the class designer the ability again to restrict a client's options to modify an object state, which is kind of very good for security. So a mutator is often designed so that the values of the variables can be set only within that particular limit. So for example, the good one is the set face value. Set face value, we know that we can only set the values from 1 to 6. So there's a restriction. So for example, the set face value mutator of the die class should restrict the value to the valid range from 1 to mass. Mass is 6, so from 1 to 6. Now in chapter 5, we're going to learn more about restrictions, how it can be implemented, which will be again our next chapters. And actually chapter 5, this is where we are going to cover the conditional statement and also the loop. So you can see that the example we have here, this one program we have, we didn't use no loops or conditions selection statements. Very simple. So chapter 5, we may get more details of the programs. So we have a quick check here also. And here we say, why was the face value variable declared as a private in the die class? Again, as we said earlier, for the encapsulation reasons or security reasons. Why is it okay to declare mass as public in the die class? Well, mass is just a variable. So we want any element in the program can use it. We don't want to declare face value as public because face value is an instant variable of the object, the die class object. But mass is just ordinary variable that we can use. It doesn't have anything to do with the object. So let's see the answers here. They say by making it private, it's very good. Each die object controls its own data, and it allows it to be what? Modified only by the well-defined operation it provides, which is the methods that it provides. And that method have to be inside the die class. Then the second one says mass is just a constant value. Its value cannot be changed. Therefore, there's no violation of encapsulation. Yeah, it's a constant value. And also it doesn't have much to do with the object itself. Okay, so let's see if we can finish our last section before time. We have like 10 minutes or less. So if no question, let's move on to the structure of a method. So we know what a class look like. We went through encapsulations. Now let's go through the method. Now a class consists of what? Data members, and the last is the methods. Now there's a difference between a function. We came to a definition saying that a function is a set of statements that when it's executed, it will perform a specific task. Method also the same thing, a set of statements, when executed, it will perform a task. But a function doesn't rely on any object or a class. So I can use a function at any time without creating no object, nothing. But a method always belongs to a class. So before I use the method, I have to create the object of that class, and always I have to refer to the object. So let's say we have object name E1. We got that object E1 from the class name employee. I want to calculate employee salary, but calculate salary is a method inside the employee class, so it's good. So I'll just write E1.calculate salary. So I have to have the object name, period. So that's the main difference between a function and a method. A method belongs to a class. When you are using it or invoking it, you have to start with the method name. So here they say, well, let's examine the method in more detail. A method declaration will specify the code that will be executed. It's the same as a function. When the method is invoked, the code will be executed. But when a method is invoked, the flow of the control jumps to the method and executes its code. Now, when complete, the flow returns the place where the method was called and continues. So we can see just by going through these attributes, a method is the same as a function. And sometimes the invocation, a method can return a value or it may not return a value. That's fine. It depends on how it's designed. But the main difference, as we said, a method always belongs in a class. So here, for example, we have a method named myMethod. It has some statements, executions. You can see that we can call this method inside another method called myMethod. So we compute it. To compute it, we need to call it in the main method. So let's see if there's an example here again. So this is a very simple example we can see. And let's see how the arrows go. So first of all, I'll write a method named doIt. Now, in order to do it, I need to call another method helpMe. So this is a helpMe method. So we can call helpMe inside doIt. Then if I want to use doIt in the main method, this is where the execution will take place. The main method is where you see we start with the object name first. So we have object.doIt. So if I call object.doIt, it will first of all do it. It will reference to the doIt method in the class or the statement. Then the process of executing is so another method again, helpMe. So helpMe, I have to go back to where it belongs to reference it. Then we get the helpMe code into doIt, execute everything, then we give it back to the main method. So this guy does the method control flow. We always call the method in the main method because that's where the execution will take place. Also, to create an object, we also have to create the object from where? The main method. I'll have a class, as we saw the die class, we have the class separately. But when I want to create objects and the type of the object is the die class, I'll go to the main method and I'll start with the name of the class, which is die. And the name of the object can be D1, D2, or whatever name you give it. The only thing we have to follow the name of Java naming rules. It cannot start with a digit, no space, etc. So now this is the structure of a method, same as a function. A method always have to start with the returning type. If it doesn't have no returning value, then it will start with the name void. Then the name of the method and the parameters here, sometimes we call the arguments, are the messages or the information that the method we use. So anytime if I call this method, I have to specify what is num1, what is num2, what is a string message. Then the code that follow will be executed. So this is called the method header. Returning type, the name of the method calc, and its parameter. If you have more than one parameter, we put space and comma between. If it doesn't have no parameter, it's possible. For example, if I write a method to print something, I don't need a parameter because if I'm printing, I don't do any calculation or anything. So I may have, still I have to have the parentheses open and close, but there's nothing inside. Because if I don't have the parentheses open and close, then Java will see it as a variable, but not a method. A method always have to have a parenthesis open and close. Either there's a content parameters or it's empty. Then this will be the method. So the method body will be our execution now, what we want to do. So in this method, we want to find the sum of two numbers. So we declare variable sum, we say sum equal to num1 plus num2. And also we want to get some character. So we have char result from the message. The message will be some strings. So we say the message.char at sum to return the character of the sum that we get. So this will be the full method now. The method header, returning type is char, the name is calc, and it takes three parameters, num1, num2. The parameters when we declare, we have to specify the type. So the first one is int, second is int, and the last one is a string. Then we do our execution operating. This will return the character of the sum. So that's why the type is char. Now, if I have only int equal to int sum equal to num1 plus num2, then I can just return the sum, or I can just write return num1 plus num2. So I don't even need to declare the variable sum. So in this case, the char will be int. So if I'm looking, I write a program to find the sum of two numbers, I'm gonna write int calc num1, num2, then return num1 plus num2, only one statement. So the returning statement is very important. If you have, it's expecting returning value, then it will return the result to the function. So if I call that function the main method and print it, the returning value that the function have, that's what we print. So for example, here I can say, okay, num1 will be 5. So in the main method, I'll say calc 5, 6, whatever message you have. Then again, we executed the main method, it will give us the results. The result will be the sum of the two numbers, etc. So here we say a returning statement always specify the value that will be returned after the execution is done. And parameters are the messages that we need to do our work. So this is where we are calling the main method. And in the main method now, we are calling the calc. So the first number is 25, the second number is count, and the message is hello. Again, when you are calling it, the data type, we don't need to include the data type, only the values. So in the method declaration, the class, we have num1, num2, the string message. But in the main method, when I create an object, my object name now is obj or object. So we say object.calc. So 25 counts. The answer here will go to the ch. So if I have a system.out.print ch, it will print the content, the result. The result will be here, return result to the function, and that will be printed. So we talk about what is a local variable. Again, because of time, our time already reached. So a local variable normally will be a variable that is declared within a method. That's the only thing I will say here. Then we have an example of a bank account example. So we will see this, and we'll go through this in the lab work. We may, hopefully next week, Tuesday, we will be in the campus because we are going to do the lab work in this chapter. We will discuss what is the driver programs later on. Right now, we don't have no time. And this is an example. Again, the slice is already posted, so you can take a look at the slice. So I'm going to end somewhere here. These are all lab work. We shall do that in class next week, Tuesday. So any question before we leave? So our main goal is the theory. We should know what is a class definition. We should know what is instant data. We should understand the concept of encapsulation and also Java modifier. The only modifiers we learn here is the visibility modifiers, which is the private and public. Again, when we cover inheritance, we shall go through the concept of protected. And also, as we said, object-oriented programming have three major benefits: encapsulation, inheritance, and polymorphism. Inheritance and polymorphism is somewhere around chapter 12. I'm not 100% sure, but we're going to cover that way after the midterm exam. We are going to cover that. We also talk about constructors already and how to declare method and their parameters also. So that's the summary. The second part of chapter 4 will be the Java FX package. So again, as I said earlier, we are not going to cover that. So let's see if we have any question before we leave. No question. Okay. So if no question, then everybody should have a good day, and we meet next week, Tuesday. So I'm going to stop the recording. Again, I'm going to post this recording in the classroom, hopefully this evening or anytime.